Find the derivative of f of x equals negative 19 e to the power of x. As we know, the derivative of t e to the power of x is the same, so it doesn't get affected by the derivative, so it stays the same. Now we have 12 ln, the derivative of 12 ln to the x. So the derivative of ln is a fraction of the number or the coefficient over x. Now find the derivative of g of x equals 3x to the power of 4 minus 7 ln of x. So we use the power rule, which is 3 multiplied by 4, which is 12 x, then 4 minus 1, which is 3, then negative in fraction, the coefficient, which is 7 over x. Now the same, power of 3 multiplied by 1, which is 3x, and 3 minus 2, which is 2. And as we said, e to the power of x doesn't get affected by the derivative, so it stays the same.
Says find the derivative of y equals e to the power of 2x squared minus 3x. So there is a formula that we have to follow, and whenever you see a function that looks like this, y equals e to the power of fx, to find the derivative it would be like this: y prime equals f, the derivative of fx, multiplied by e of x. And so we're gonna apply that to this right here. So, and we'll write it right here. So y prime will equal to the derivative of fx, which is this one right here. And so it would be 4x minus 3. And then we would write e to the power of fx, which is this right here. And we wouldn't change anything about it, so we'd write it as it is. So e to the power of 2x squared minus 3x. And the answer would be A. So for the next question, it says find the derivative of y equals 5x. And for this function, it can also be represented by y equals ax. And whenever you see a function like that, to find the derivative y prime, you'd have to write it like this: ln a multiplied by ax. So to find the derivative of this function right here, y prime, and then we'd follow the formula right here, which is ln and then 5 multiplied by 5x. So the answer would be B. For the third question, it is asking us to find the derivative of y equals ln x to the power of 2 plus 3x. And this function right here can also be represented by y equals ln and then fx. And whenever you see this function, you will always use this formula right here to find the derivative, which is y prime equals the derivative of fx divided by fx. And let's now solve this function right here. So to find y prime, we're going to follow the formula that's above of us, and which is going to be, we're going to find the derivative of this, the one in the bracket, fx. So it's going to be 2x plus 3 divided by x squared plus 3x, which is the first one, A.
Find the derivative of f(x) equal to ln 2x power 3 plus 5x power 2 minus 3. So first thing first, 2x power 3 plus 5x power 2 minus 3 is our f of x. So the derivative of f(x) is equal to the derivative of f of x, which is 6x power of 2 plus 10x. And our denominator gonna be just fx without changing anything. In our case, it is 2x power of 3 plus 5x power of 2 minus 3. And this is the answer. Our second question is, find the derivative of y equal 3 ln x power of 2 minus 3. Y prime is equal to 3 times, so x power of 2 minus 3 is our f of x, times the derivative of f of x, which is 2x over x power of 2 minus 3. And now we're just going to simplify it. So 3 times 2x is equal to 6x over x power of 2 minus 3. So our answer is A. And our last question is, find the derivative of y equal ln 3x power of 2 minus 5x. Again, 3x power of 2 minus 5x is our f of x. Our y prime is equal to 6x minus 5 over fx without changing anything. In our case is 3x power of 2 minus 5x. And our answer is A. Hope you understand the rule of ln of fx, and thank you.
Find the derivative of cosine in brackets e to the power of x. So in this situation we'll be using chain rule, which is f prime of g of x multiplied by g prime. So what do we mean by f is what is out of the bracket, and what do we mean by g is what is in the bracket. So let's start with finding the derivative of f, which is the derivative of cosine. The derivative of cosine is negative sine. Then we need to put the g as it is. So we open the bracket and we keep it e to the power of x. And then we need to multiply it by the derivative of g. So we open a bracket, and as we said, the derivative of e of x stays the same because e of x doesn't get affected by the derivative. So it stays the same, e to the power of x. Now we just need to change the place of e of x. So we switch it to the front. So negative e of x sine in brackets e to the power of x. So that will be our final answer. Now let's check it out here. So that will be our answer. Let us check it. And we got it correct. Find the derivative of y equals e to the power of x over x. So in this situation we will be using quotient rule, which is the derivative of f of x over g of x is g of x multiplied by f of prime minus f to the multiplied by g prime over g squared. So as we can see, let's first label the fraction. The top part of the fraction is called f and the bottom one is called g. So let's start. The derivative of y is y prime equals, we start opening the brackets, The first bracket needs g, so x multiplied by f prime, which is the derivative of e of x. The derivative of e to the power of x stays the same because it doesn't get affected by the derivative, minus f, which is e to the power of x, then multiplied by g prime, which is the coefficient of x, which is 1, over g squared, which is x squared. Now we start multiplying the bracket. X multiplied by e of x, e to the power of x, is x and e to the power of x. Then negative e to the power of x multiplied by 1 is negative e to the power of x over x squared. Now let's choose the answer that matches our final answer, and it will be option A, because e to the power of x multiplied by x will give us x and e to the power of x, and e to the power of x multiplied by negative 1 will give us negative e to the power of x over x squared. So let us choose it and let us check our answer, and you got it.